Okay, students, now comes question number 7. You are given with a vector function f of x, y, z to be xi plus yj plus zk, and the curve here is C, which actually is a circle with center 0 and 2, because this is x squared plus y minus 2 the whole squared, and its radius is 3 because the square root of 9 is 3. Then you are asked to find the line integral of this vector function over the curve. So this recalls how you can carry out line integral of a vector function over a certain curve, in our case a circle. So basically this is done in two different ways. So I'm now going to show you how this can be done by using first approach, and next I will tell you a shortcut technique how you can obtain solution of this kind of question. So when I directly go to the solution part, you see this is going to be like this. As you know, dear students, whenever you want to find the line integral of different function, it could be scalar or a vector function, what you need to do is you have to know the parametric vector equation of the curve, because as we know, the line integral is defined on that particular parametric vector form. So as you know, this is a circle with center at 0, 2, and the radius 3. And if you remember, students, every circle with a radius 3 has making its center at the origin has an equation of r of t is equal to 3 cos ti plus 3 sin tj. And here, look, 3 cos ti plus 3 sin tj represents the equation of a parametric equation of a circle with center at the origin in the radius 3 unit. But now the center is moved. See, the center is moved to 0 and 2 because 2 minus 2 makes 0. So the center has shifted from the origin to 0 to 2. So we need to use translation property. So if the center moves from 0, 0 to 3, 2, again the parametric equation changes, and the parametric equation is nothing but it is adding 0 and 2 on 3 cos t and 3 sin t respectively. So you will finally come across with the parametric equation of this circle to be 3 cos ti, because 0 plus 3 cos t, 0 is 3 cos ti, and the 2 plus 3 sin t is going to be 2 plus 3 sin t along the j component. So for one complete revolution of a circle, our t runs from 0 to 2 pi. So this is going to be the parametric equation of the circle given by x squared plus y minus 2 the whole squared equals 9 for t running from 0 to 2 pi. Once we have this, now what comes next is the assignment. So here x is your 3 cos t, because as you see the x component of your parametric equation is 3 cos ti. So the x is going to be 3 cos t, so directly you can know what dx is. The change on x is going to be minus 3 sin ti, it's minus 3 sin t dt. And if y is going to be 2 plus 3 sin t, and the derivative of this respect to y with respect to t is going to be dy is equal to 3 cos t dt, because this one is a constant one, it will be 0. So the derivative of 3 sin t is 3 cos t dt. So dear students, every variable is now written in terms of t. So later when I use this expression and write in terms of t, everything can be obtained. This the integral of f dot dr is going to be like this, as it has been given here. Your f is xi plus yj plus zk. So I just directly took this one and wrote it here. You see, n dot what is dr? Dr is dxi plus dyj plus dzk, because we are in 3 axes, x y z. So we need to have dr to be dxi plus dyj plus dzk. So this integration is going to be, you see, the integral of dot product of two vectors, which actually is this one. What I did here is just simply substituted what x is 3 cos t, and y here is 2 plus 3 sin t, and your z is we don't have z component here, right? Yeah, it's good. So if you don't have the z component here, you see we will consider that to be 0k, right? 0k because the z component here is, you see, what is that, j, and what was that? Yeah, this is totally given in terms of, it is given on xy plane, so we don't have k component here, it is 0, so you do have here 0k, so I'm not going to write that. Dot row is, what is dx, students? Dx is nothing, but it's the one obtained here, minus 3 sine t dti. And what is dy? It's already done, 3 cos t dtj. Since z is 0, dz is going to be 0, so we are left with this. So everything is written in terms of t, so we need to write t's interval. So our t runs from 0 to 2 pi, so this here we have 0 to 2 pi. So how are you going to do this dot product? So remember how we can carry out dot product into vectors. So this is 3 cos t, it will multiple minus 3 sine t, and it will be minus 9 cos t sine t. And this must multiple this, 2 times 3, 6 cos t, and 3 sine t, 3 cos t makes 9 cos t sine t. So altogether we do have this one. Look, if you observe this first expression and the third one, you see one is the negative of to the other. So one can cancel the other, and then we can have the integral from 0 to 2 pi of 6 cos t dt. So can we take 6 as a common out? Yes, and then sine t can come, but as you are substituting 2 pi and 0, 1 after the other in place of sine, this comes to be 0 minus 0, and it will be 0. You see, student? So this is the first technique that we can do. And when we come to see the other concept, you need to recall this one. Remember, students, we studied this. If f here, capital F, the vector 1 is the gradient of a certain scalar function, we call this function, the vector function f, conservative field. So clearly f is conservative because it is the gradient of a scalar function, this one. Basically this is f of xyz, student, f of xyz, okay? Please correct that by that. A function of 3 variables, scalar function, 1 over 2 x squared plus y squared plus z squared. So if you carry out gradient of this one, you will finally come across with this. So if capital F behaves this kind of property, if capital F is a scalar, a gradient of a certain scalar function, the scalar function is called the potential function, and the one taken here as a vector is considered to be the conservative field. So if f is conservative field, students, then it is path independent. That is to say that it doesn't depend on the path we are moving from the initial to the terminal one. Instead, it depends on the initial and terminal points. Since we are having a circle here, you see the initial point and the terminal point coincides. So this is going to be, you see, this value at, you see, this value at the end point minus this value at the initial point. Since the initial and the terminal points are identical, and since we are also having same function, the result comes 0. So you need to know, student, that if f is conservative field of a certain scalar function, the integration is called a path independent. And moreover, since again the curve is a closed one, the path independent integral goes to 0. It has to be noted. So after having this, what comes next is another question, and this is the 8th question. You are asked to find the work done by a certain force given by 3y to x 4z that moves a certain particle along the curve C from, you see, 0 to 1 of t value by this position vector r of t. So let's calculate that in terms of joule. Assume that this is given in terms of Newton and this is given in terms of meter. So in a way, this is obtained in the following way. Your r of t is ti plus tj plus tk, and t runs from 0 to 1. So from this, your x is t. Clearly, your x is t, so the derivative of x is dt. You do have also dy to be what? Dt, because y is t, and the same is true for this. Dz is dt because z is t. So from this, what follows is the integral of f dot dr is going to be 3yi plus 2xj plus 4zk, directly taken from this one, dot with drs dxi plus dyj plus dzk. So having this what's called dot product, we can have 3ti plus 2tj plus 4tk, dti plus dtj plus dtk. So carrying out this integration, you do have 0 to 1 because t is running from 0 to 1 as I wrote over here. Then 3t, 2t plus 4t can come, just applying this dot product. And finally this makes, actually I can also add this, 3t plus 2t plus 4t makes 9t, and 90 squared over 2 can come, and as you are substituting these values, 9 over 2 can come, but I can also perform the integration for each of these. But as I said earlier, this is integral of 90, so 90 squared over 2 can come, and as you are substituting 1 and 0 one by one, you will encounter 9 over 2 as a final output. So if this force is given in terms of Newton, and if this is given in terms of meter, this much amount of joule is going to be done by the force in order to, just by doing a certain work.